All right, in this video, I am going to do lesson 12.4, law of cosines. And go ahead and start with going over the basic formula here. Okay. So in the law of cosines, this has to do with a triangle. And we're going to label this triangle A, B, C, just like we did for law of sines. Let's go A, B, and C. And again, the lowercase letter is going to be opposite the angle. So B, A, C. Okay. Now, this equation is basically going to come from, if you were to make a right triangle here, and let's call this like x, and this would be c minus x. And you did the Pythagorean theorem for both of these. And we could call this, let's say, maybe h. And if you do the Pythagorean theorem for both of these, and then combine them together and do some math, you're going to get this equation. So this equation will look very similar to the Pythagorean theorem, but there's one slight catch because we don't really want to use x in this one. And so what they do is they say, well, we know cosine of A is equal to x over b. And then we know that cosine, and so what we can do then is go ahead and multiply both sides by b. So b cosine A is equal to x. So whenever we see x in the equation, we're going to substitute it with b cosine A. And so that's why this ends up being the law of cosines. So we're not going to get into that in this video. But just to say that that is why it's a law of cosine. Now, there is no law of tangent, in case you're wondering. Just law of sines, law of cosines. And this, again, is used on non-right triangles. And it's when you have either in all the sides and none of the angles, or you have a side, an angle, and a side. So an included angle and two sides. And so these are the two cases where you can't use law of sines. And so that's why you have law of cosines. So let's show you what it looks like. This is looking like c squared will be equal to a squared plus b squared. Nothing surprising. That's basically the Pythagorean theorem. But then we're going to do minus 2bc cosine of c. Okay. And, hold on. Typo here. 2ab. There we go. Cosine c. So what you'll notice is that this letter and this letter matches, and that you have lowercase c and uppercase c. You'll also notice that A and B match right there. And so unlike the Pythagorean theorem, this one, there is no hypotenuse here. So C isn't necessarily the hypotenuse, because it's not a right triangle. So you can rearrange these letters however you'd like. And I'll go ahead and show you that in this next example, right? So in this example down here, notice how we don't have A, B, and C. We have R, S, R, and T. Can we still use the formula? Absolutely. However, in this case, we're trying to find ST. We're trying to find R squared. So what we're trying to find is going to go all by itself. Trying to find R. And then I'm going to put the other two sides right here and subtract off 2 times those two sides. And then the cosine, what do I do the cosine of? Well, if I'm trying to find side R, I'm going to do the cosine of angle R. Okay. So I'll go over this one more time. That means this equation above, you can actually also do b squared equals a squared plus c squared minus 2y. What am I going to put next to the 2? Yeah, I'm going to put AC cosine of what angle? B. And you guessed it, you can actually do this for A as well. So A squared equals B squared plus C squared minus 2 what? BC. Cosine of what angle? A. So these equations are all the law of cosines, and they will all work. And so down here in this one, let's go ahead and just plug everything in. So r squared equals s is 45 squared, and t is 52 squared minus 2. Now, what do we multiply by here? Well, 45, 52 times the cosine of 36 degrees. Yeah. Okay, so now that we have this, the next step is just going to be plugging all of that into the calculator. So it kind of is a plug and chug problem. I'll go ahead and do that here. Okay, so again, make sure we're in degree mode. Okay, so let's see. So let's go 45 squared plus 52 squared minus 2 times 45 times 52 times the cosine of 36 degrees. Enter. 942.80. So that'll just be 942.8. So r squared equals 942.8. And now what I'm going to do is just square root both sides, and that will give me my r. And so let's go ahead and go back to my calculator. So it's kind of cool. I can go second square root, and rather than typing it in, just go second answer. That's the ANS key above the minus sign at the bottom there. And that will give me the square root of that number. So 30.7, so about 31, looks like. And that's an approximation, so use that sign. Approximately equal to 31 centimeters, and that is my answer. Okay. Now, you can also use law of sines in another case. So this was the side angle side case. But what if you have all three sides like this? Side, side, side. And we can go ahead and do that. So 250, 225, 175. Let's label this A, B, and C. This will be side A, side B, side C. And so we're going to try to find the measure of the largest angle. Now, as you know, in a triangle, the largest angle is always opposite the largest side. So we're going to do that. Now, as you could imagine, if you're trying to, find the angle, that means that you're plugging in A, B, and C and trying to solve cosine C, which is a lot of algebra. But the nice thing is that there's actually an equation you can do, and we'll do this one. So it turns out cosine of C is equal to A squared plus B squared minus C squared divided by 2AB. How did they get that? Well, they just took that equation that I first showed you and did some algebra to rearrange it. So we can use that in our problem. So that means that cosine of C equals A squared plus B squared minus C squared. Let me just make sure I have that. Hold on. Yep, divided by 2AB. And now all I do is plug and chug. So cosine of C is equal to 225 squared plus 175 squared minus 250 squared divided by 2 times 225 times 175. Okay, so now that I have that, I'm going to go ahead and plug that into my calculator. And let's go ahead and do that. So let's see, in this one, I'm going to have to be very intentional how I use parentheses. So 225 squared plus 175 squared minus 250 squared divided by, and in this one, you'll notice that if I go dividing by right now, then I'm only going to divide negative 250 by this. So I actually have to insert a parentheses around this. Or what you could do is just, go enter and then divide this by the whole thing, which is probably a little bit easier. Let's divide this by the bottom and make sure you put all of this in parentheses. 225 times 175 and enter, and you get 0.2. Now, if you're doing this right, you have to get a number between -1 and 1. So if it's more than 1 or less than -1, then there was a mistake made. Like, for example, if you do inverse cosine of 1.1, you will get a domain error, and that's what you're supposed to get. So you can only inverse cosine. I'll just go ahead and do this again. I'm doing second enter right now in case you don't know, to get what I did last. Okay, so now I'm going to inverse cosine this number, and that will give me the angle measure, right? Pretty cool. So now what I'm going to do again is go back here, and this means that cosine of C is approximately equal to 0.2381. And so C is going to be approximately equal to inverse cosine of this number, which means C is approximately equal to 76 degrees. Okay, so that's how you do it with side, side, side. And then with the last problem here, really quickly, I'm just going to call this E. So E squared is going to equal 22 squared plus 22 squared minus 2 times 22 times 22 times cosine of 125, right? So this, again, notice how E matches E. And this is a side angle side case. All right, so I'll go ahead and let you finish this problem. And that will conclude the 12.4 notes. Thank you for listening.